talking about the architecture of conversation in LangChain. It's really the matrix moment for AI developers. You know, you spend all this time with ChatGPT or Claude and you just see these smooth bubbles of text.
Right.
But if you're building these systems, you have to stop seeing bubbles and start seeing structured objects. If you treat an LLM interaction like a text message, you're just going to hit a ceiling very, very quickly. By the time we wrap this up, there are, I think, 4 specific things I want to make sure we've nailed down. Okay, lay them out. First, we need to really understand the anatomy of the message object itself, the container. Well, second, we have to be able to spot the difference between the captive characters, system, human, AI, and the tricky one, the tool message. That's a big one. Third, we need to know when to be lazy and use a simple string versus, when to be professional and use a message list. Yeah. And finally, this is the big one. We are going to walk through the flow of a tool call step by step because that is where everyone gets confused. Absolutely. That last one is the killer. I mean, the tool call loop is where probably 90% of bugs happen in production. But once you can visualize the data structure, it stops being magic and it starts being engineering. So let's activate some prior knowledge here. Everyone listening has used a chat interface. You type hello, the bot types hi. You scroll up, you see the history. It feels like the bot remembers you. It does. But let's be real, technically, that bot doesn't remember a thing, does it? Not a single thing. It's stateless. Every single time you hit enter, the application is actually taking your new text, bundling it with a list of everything you've said before, and just shoving that entire stack back into the model. The whole thing. The whole thing. That memory is just a list object that you, the developer, have to manage. So the message is a fundamental atom of context. If you get the atom wrong, yeah, the whole universe just falls apart. Exactly. And in LangChain, they've formalized this. A message isn't just a string in a database, it's a Python class. And if we look at the anatomy, it's surprisingly consistent. No matter which model you use, a message object basically has 3 core components. I was looking at the source code for the base message class. It's pretty rigid. You get role, content, and metadata. That's the holy trinity. The role is the who. Is this the user, the system, the AI? The content is the payload, usually text. But as we'll see later, it's getting pretty crowded in there with images and tool calls. And then metadata. And metadata always feels like the junk drawer of programming. Yeah, I know. Just put the extra stuff here. But in this context, it seems pretty critical. It's not junk. I mean, think about it. If you're paying for every single token you send to OpenAI or Anthropic, you need to track that. Oh, right. The usage metadata field in these message objects tells you exactly how many input and output tokens that specific message consumed. If you aren't tracking that metadata, you're flying blind on costs. Good point. Okay, so we have the container. Now let's talk about how we use it. The documentation highlights a function called inAChatModel. It seems like the standard entry point now. It is, but it allows for 2 different ways to talk to the model, a text prompt or a message prompt. And this is a classic scaffolding situation. When you're just starting out or you're just doing a quick test, you use a text prompt, which is just a string, like model.invoke, tell me a joke. Right. It's simple, it works, but it's a trap. Why is it a trap? Because it assumes a stateless one-shot interaction. If you send a string, LangChain quietly converts it into a human message for you in the background. But you lose all control. You can't set a system persona easily. You can't provide history. Actually, if you want to build anything more complex than a Hello World app, you have to graduate to the message prompt. And this is where we pass a list. System message, human message, a message. And I think this is a good moment for a metacognitive check. If I'm a developer listening to this, I might be thinking, why do I need to type out all these class names? Why not just send a string formatted like a script? You could do that, but then you're relying on the model to parse your string correctly. By using the object system message, human message, you are speaking the API's native language. You're explicitly telling the API, this part is instruction, this part is input, it's safer, and more importantly, it allows you to separate the behavior from the content. That brings us to the cast of characters. Let's break these down because they aren't just labels, they actually change how the model processes the text. Let's start with the system message. This is the director of the play. It sets the rules. A system message typically sits at index 0 of your list. It says things like, you are a helpful assistant, or you reply only in JSON. I've seen some debate on this actually. How much does the model really care about the system message? Can't the user just override it? That's the eternal struggle of jailbreaking. But modern models, especially the newer GPT-4 variants and Claude 3, they're really trained to treat the system message as the Constitution. The Constitution, I like that. Yeah, if the system message says, do not discuss politics, and the human message says, who should I vote for, the model should prioritize the system instruction. It's a much stronger constraint than just asking nicely in the user prompt. Okay, then we have the human message. That's pretty self-explanatory. It's the user input. But I did notice the docs mention a name field. Yeah, that's useful for multi-user context. If you're building a Slack bot where Alice and Bob are both talking to the AI at the same time, you can tag the human message with name Alice. Oh, I see. It helps the AI distinguish between different speakers in the history so it doesn't get confused about who said what. Makes sense. Okay, next up, a message. This is the response. But lately, this object has gotten heavy. It's not just text anymore. No, it is packing a lot of luggage. Aside from the text response itself, the A message contains response metadata. This is where you find the finish reason. Right. Did the model stop because it finished its thought, or did it stop because it hit the token limit? Which is a huge difference if you're debugging why your bot just cut off mid-sentence. Precisely. If finish reason is length, you know you need to bump up your max tokens. If you didn't have the object, you'd just be staring at a half-written sentence wondering what broke. Now, before we get to the really complicated stuff, I want to touch on content. We said earlier it's the payload. In the old days, like, 2 years ago, content was just a string. Yeah, the good old days. But now we have multimodality. We're sending images, audio, PDFs. How does a single content field handle all that mess? Well, it handles it by becoming a list of blocks. This is really where LangChain shines with its universal language concept. If you want to send an image to OpenAI, the JSON looks one way. If you want to send it to Anthropic, it looks totally different. LangChain says, forget that, just give me a list. So instead of a string, I set a list containing, say, a text content block and an image content block. Exactly. You stack them. Block 1, describe this image. Block 2, the actual image data. LangChain's internals then translate that into the specific format the provider needs. And I saw a new one in the docs. Reasoning content block. Is that for those new reasoning models? Yes, exactly. Like the O1 preview or DeepSeek models. These models think before they answer. They generate this internal monologue that helps them solve logic puzzles. Sometimes you want to see that thinking, sometimes you don't. LangChain captures that private monologue in a reasoning content block, so you can display it like in a little drop-down UI separately from the final answer. It keeps the UI clean, but keeps the data accessible. That portability is key. You don't want to rewrite your entire code base just because you switched from GPT-4 to Claude. That's the whole promise of using these objects. We've scaffolded the basics. We know the container. We know the types. We know the content blocks. Now we need to tackle the beast. Tool calling, cool calling. Let's do it. This is where I see developers get the most frustrated. The flow creates a loop that is just so easy to break if you don't understand the objects. Yeah, sure. So let's do a worked example. We're going to visualize this slowly. Okay. The scenario. A user asks, what is the weather in Paris? We have a function available called getWeather. Walk us through the message flow. Step 1 is the user asking. Okay, step 1. The request. You send a human message, content, what is the weather in Paris? And crucially, in the API call, you also pass a tool definition that describes your getWeather function. Okay, step 2, the decision. The model gets this. It thinks, I don't know the weather, but I see a tool that does. It generates a response. What does that A message look like? This is the common misconception. People think the AI runs the tool. It does not. The A message comes back with empty string content. No text. No text at all. Instead, it has a populated tool calls attribute. So it's basically writing a ticket, like a waiter writing an order to the kitchen. That's a perfect analogy. The AI is the waiter. It writes a ticket that says, please run getWeather with the argument location Paris is. And this is vital. It stamps that ticket with a unique ID. Let's call it call123. Okay, so now my application, my Python script, is holding this A message. It sees the tool call. Step 3, the execution. The AI pauses. It's just waiting. Your code takes that ticket, sees getWeather, and it actually runs the Python function. It hits the weather API and gets a result. Sunny 72 degrees. Now we have the answer. But the AI doesn't know it yet. We have to tell it, this is step 4. We need to send that result back. And this introduces our 4th character, the tool message. Right, and this is where the system is fragile. To create a valid tool message, you need 2 things. First, the content, sunny 72 degrees. Second, you absolutely must include the tool called. You have to paste call123 into that message. Why is that ID so non-negotiable? Because in a complex system, the AI might have sent 3 tool calls at once. Get weather for Paris, get weather for London, get the stock price for Apple. If you just send back 72 degrees, the AI has no idea which question that answers. The ID links the result back to the specific request. I've seen that error log. 400 bad request. Tool message must correspond to a tool call. That's essentially the AI saying, I didn't ask for this, or I don't know where to file this information. Exactly. If you lose that ID, you break the conversation chain. Simple as that. There's one more nuance in the tool message I want to highlight. The artifact field. It sounds like something from an archaeological dig. It's a brilliant feature for developers. Sometimes a tool returns a huge amount of data. Let's say you're doing a RAG search retrieving documents. The tool finds a 50-page PDF, right? You want the AI to read the summary, but you, the app developer, need the file path, the page number, and the author to show a citation link in the UI. But you don't want to shove all that metadata into the AI's context window. It's expensive and it's just distracting. Right, so you split it. You put the text summary in the content field, that's for the AI. You put the raw file path and the metadata in the artifact field. The model ignores the artifact entirely. It's a secret channel just for your application card. Wow. It passes data through the message history without confusing the bot. That is extremely useful. It keeps the context clean. And clean context means smarter models. Okay, I want to do a formative check-in here. We've talked about these message types. System, human, AI, tool. We've talked about the flow. I want to pose a challenge to you, the listener. Well, I want you to imagine you are building a lot that needs to be, well, gaslighted, for lack of a better term. You want to start a conversation where the AI believes it has already told you a joke. And you want to trick it into explaining the punchline even though the joke never happened. How would you structure the message list to make that happen? Think about it. You need to fabricate history. Which objects do you need? Well, I think you'd start with a system message to set the rules. You are a comedian. Right. Then you would insert a human message. Tell me a joke. But you don't actually send that to the model yet, correct? Then, and this is the trick, you manually create a name message. You write the content yourself. Why did the chicken cross the road? And you just append that to the list. So the list you finally send to the model is system, human request, and then AI, response. And then you add one final human message. I don't get it. Explain the punchline. So when the model receives that stack, it looks at the history. It sees an A message that says, why did the chicken cross the road? It just assumes it generated that. And it proceeds to explain a joke it never told. It will happily proceed to explain a joke it never actually told. That's context engineering. You are manipulating the state of a conversation by manually assembling the message objects. It really drives home the point that the AI has no memory, only the list you give it. It creates a lot of power. You can fix bad behaviors, you can steer conversations, or you can even correct mistakes by rewriting the history before the next turn. So bringing it all together, we've covered the anatomy, the types, and the tool loop. How does this transfer to the real world of high-performance apps? I'm thinking about screaming. This is why the object model pays off big time. When you use an app and you see the text appearing word by word, that's streaming. Under the hood, LangChain isn't sending you full A-message objects, it's sending A-message chunk objects, chunks, tiny fragments. But here's the cool part. A-message chunk supports addition. You can literally write code that says chunk 1 plus chunk 2, like Python addition, on objects. Yes, if you add 2 chunks together, they just merge their content. So if you capture a stream of 50 chunks and add them all up, the result is a perfect, complete A message. That's clean. This works for tool calls too. You get tool call chunks, you assemble them like Lego bricks as they fly in over the wire. If you didn't have this object structure, you'd be doing complex string parsing on partial JSON, which is a total nightmare. It transforms what could be a really messy string manipulation problem into a clean object-oriented problem. Exactly, and it makes debugging possible. If a user complains the bot broke, you don't ask, what did you say? You ask, show me the trace. You look at the list of objects. Oh, look, the tool message has the wrong ID. Or the system message was missing. Precisely. You can inspect the state of the machine perfectly. That's the difference between hacking a script and engineering a product. 100%. We are coming to the end of the deep dive. We've covered a lot of ground. But before we go, I want to leave the listener with one final provocative thought. The field is moving so fast. New models are coming out every week with weird new features. Always. What happens when a model releases a feature that doesn't fit into text, image, or tool? That is the unknown unknown, and LangChain actually has a solution for it, which I think is fascinating. It's called the non-standard content block. That sounds like a hazardous waste container. It kind of is. It's an escape hatch. If a provider like Google or OpenAI releases some weird new feature, maybe haptic feedback or smell-o-vision, and LangChain hasn't standardized it yet, the library won't crash. Okay. It will just wrap that data in a non-standard content block. So it basically says, I don't know what this is, but I'll hold it for you so you don't lose it. Right. It guarantees that even as the protocol evolves, your application remains stable. It's a good reminder that we are building on shifting sands. The message object is our best attempt to create a stable protocol for an industry that changes every Tuesday. Stability in chaos. That's the goal. It is. Thanks for unpacking this with us. Hopefully next time you see that chat bubble, you'll see the matrix code underneath. And remember, watch your tool copilots. We'll catch you on the next deep dive. Happy coding.